Okay, the logistics growth models. Some populations initially have high rapid growth, followed by a declining rate of growth, as indicated in the graph here. One model for describing this type of growth pattern is the logistics curve. And in the logistics curve, the y will always be our population size, and x is going to be our time. So on this slide, remember the big thing that we looked at was that the logistics growth curve is also called the sigmoidal curve. So if you hear either of those words, they're talking about the same thing. So for example 5, we're talking about the spread of a virus. It says on a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by that equation, where y is the total number of students infected after t days. The college will cancel classes when 40% or more of the students are infected. How many students are infected after 5 days, and after how many days will the college cancel classes? All right, so let's work on these problems here. So A was after 5 days, the number of students infected is. Well, after 5 days, is 5 going to be my t or is it my y? Well, if you look back, it tells you after t days. So t must be 5. So we're just going to plug that into our equation and solve. So let's do that now. Okay, so we've plugged this into our equation, and we need to make sure we plug it into our calculator. Now be really careful on how you do this. Remember, this entire bottom needs to go in parentheses because we're saying we're taking 5,000 divided by all of that. All right, so we plug this into our calculator, and we get just a little bit more than 54, but we're talking about the number of students. So you can't have a piece of it or anything. So it says after 5 days, the number of students infected is 54, period. And there's my sentence. B says the college will cancel classes when? Well, we know it's when 40% of the students are out, are infected. So how many students is that? Well, let's see. It's 40% of, which means times the number of students. And it said in this problem that there were how many students? There were 5,000 students. So 0.4 times 5,000 gives us the 2,000. So we know that they're going to cancel classes when 2,000 students are out. But when will that happen? Because the original question said after how many days will the college cancel classes? So we got to find the number of days. So let's plug this into our equation. Okay, so I plugged in 2,000 for the number of students, and we need to solve for t. Well, the first thing we got is we don't like that fraction, so let's get rid of it. And remember, you always then multiply by what's on bottom, or technically you could put the 2,000 over 1 and cross multiply. Either way, you get the same answer. So I'm multiplying by all of this that was on bottom. And what we do to one side, that's going to make that cancel. We got to do to the other. Now I'm out of room here, so it's going to have to be real little, but thankfully this is a darker color, I guess, so you can see it better. Alright, so I'm not actually going to multiply the 2,000 through that or anything. I'm just going to write them separate. So I ended up with 2,000 times 1 plus 4,999 times e to the negative 0.8 t is equal to 5,000. Now t is in that exponent that is stuck inside the parentheses. So first thing I need to do is try to get the parentheses by itself. So let's divide by the 2,000. So my 2,000 is gone over here, and I get 1 plus 4,999 times e to the negative 0.8 t equals 5,000 divided by 2,000 is 2.5. Then we're still just slowly working our way in to get e by itself, so let's move that 1 over. So we got 4,999 e to the negative 0.8 t equals 1.5. Still need to get e by itself, so let's divide both sides by that 4,999. And I'm out of room here at the bottom, so I'm going to bring it up here to the top because we have lots of room up here. Alright, so when I do that, let's see, I get that e to the negative 0.8 t equals. Now when I plug in 1.5 over 4,999, I get a really ugly number. So I'm just going to leave it for right now as 1.5 over 4,999. I can do that because it's not my final answer. It's just a piece of the work. Still going to have the same value. All right, and again, now I've got exponential, or you can say that we can log both sides. It doesn't matter. I think in class, I think all the classes went ahead and logged both sides, so I'm going to go ahead and do that with y'all. So let's see, we've got a base e, so we're going to do the natural log. So the natural log of e to the negative 0.8t equals the natural log of 1.5 over 4999. Okay, then we can bungee our exponent. So I've got negative 0.8t times the natural log of e equals the natural log of that fraction. Notice that 4999 is inside the parentheses there. Don't try to divide everything by it. Alright, and we know the natural log of e is 1. So let's divide by that negative 0.8. When I do that, I get t equals, and we just type that in our calculator. So take the natural log of 1.5 divided by 4,999, get an answer, and then divide that by negative 0.8. And you end up with like 10.1 something days. But so there's not enough people infected at the beginning of the 10th day. So the 10th day, they're not going to cancel classes. So it's going to take them 11 days to cancel classes. And that's example 5.